Now, not all confidence intervals are going to be based on a mean. We can also create a confidence interval for a total. Now, it's a little bit less intuitive, but let's say we're trying to determine our total revenue for all customer accounts. So T represents the population total for estimation, and the T with the little hat over it represents our point estimate for the total. And what we're basically saying is that if we knew individual accounts and we had a sample of the accounts, and we knew that our entire population of customers was, say, 100,000 or a million, we could calculate an estimate for the total and get a confidence interval for that total. So our point estimate for the total is basically given by this T hat, which is equivalent, we'll do the right side because it's a little bit easier, the total population times our sample mean. Thus, our expected value for T hat is going to equal T. So our expected value of the point estimate should be the actual total. Our standard error for the T hat, for that estimate, is going to be equal to N, which is our total observations, divided times the population standard deviation divided by the square root of N. So we can therefore estimate this by fixing the standard error of the T hat to equal N times our standard error of the sample mean. And thus we have the following confidence interval: T hat plus or minus the T multiple times the standard error of the predicted total. So let's take a look at an example for this. From the data set on the right, we have 100 samples of our customer revenue accounts, but we only show 17. We calculate our mean and standard deviation, which you can see on the right is 2601, and the standard deviation of 1430. We also have calculated the standard error and the T multiple in the yellow box. And we include a total estimate, which is our T hat for the total estimate, which is equal to the total number of observations times our average sample, where N is the total population. So therefore, we have our T hat plus or minus the T multiple times the standard error of that T hat estimate. Again, our T multiple was calculated using the T.inv.2t function for the two tails. We use 0.05 because it's a 95% confidence interval, so we do 1 minus 95%, giving us 0.05. We have 100 samples of customer revenue accounts, so therefore we're going to take 1 minus that and get 99. So therefore, what we do is, in order to calculate it, at the bottom we have another set of boxes which says our total population size is going to be 10,000. So our total estimate is going to be our mean, which was 2601, times the 10,000, giving us 26 million. Our standard error total, which we calculated, is going to be 1430082. Now when we do this, we're going to create a 95% confidence interval for the total. So that's what is on the bottom. The 95% confidence interval in the yellow box would be the confidence interval for the mean itself, but we've extended this to include the total. And we end up with 26 million plus or minus 1.984, which is our T multiple for this, times 1430082. And we'll end up with a 23 million on one side and 28 million on the other side. Our 95% confidence interval will be between 23 million and 28 million.